Hello, welcome friends. Me Anila. The topic of my discussion is about electronic configuration. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to identify elements by electronic configuration. What are atoms? Atom is the smallest entity consisting of three subatomic particles. One is electron, second is proton, third is neutron. Neutron is neutral in nature, proton is positive in nature, electron is negative in nature. Proton and neutron are in the middle, forms the nucleus, and electron revolves around the nucleus. The spin of electron. When an electron moves, it creates electric field as well as magnetic field. These electrons in the electronic configuration, they have different orbitals shape such as s orbital having spherical shape, p orbital having dumbbell shape, d orbital having clover leaf shape, and f orbital having complex shape. In this video, I will tell you how to identify elements by electronic configuration. Example number 1. An element has electronic configuration 1s2, 2s2, 2p6, 3s2. Identify the element and its magnetic nature. So this 1s, 2s, 2p, 3s, this is arranged according to Aufbau principle. The lower subshell have is filled first by electrons. First 1s, then 2s, then 2p, then 3s. S orbital can hold maximum 2 electrons. P orbital can hold 6 electrons. So we have to identify the element and its magnetic nature. Solution. We will count the number of electrons. 1s2, 2s2, 2p6, 3s2, 224 plus 610 plus 212. So the total number of electrons are 12, and the number of electrons in a neutral atom is equal to number of protons. So atomic number is 12 and atomic weight is 24. So it is magnesium. Magnesium is an alkaline earth metal because in the electronic configuration, s orbital can occupy 2 electrons, p orbital can occupy 6 electrons. All electrons are paired, so it is diamagnetic in nature. Why paired? Because in the 3s orbital, s orbital can occupy only 2 electrons, one with clockwise direction, other with anti-clockwise direction. So s orbital can hold 2 electrons. So because of pairing of electrons, it is diamagnetic in nature, means weakly repelled by magnetic field. So the element is magnesium. Example number 2. Electronic configuration is 1s2, 2s2, 2p6, 3s1. Identify the element and its magnetic nature. 1s, 2s, 2p, 3s we have written according to Aufbau principle. The lower energy is 1s, higher energy is 2s, much higher is 2p, much higher is 3s. S orbital can occupy 2 electrons, p orbital can occupy 6 electrons. Now we have to identify element and its magnetic nature. Solution. First we will calculate total number of electrons. 2261, it becomes 11 electrons. And number of electrons are 11. So in a neutral atom, proton numbers are also 11. So it is sodium, because sodium has 11 protons and 11 electrons. Now we have to find its magnetic nature. One unpaired electron, so it is paramagnetic in nature, that is weakly attracted by magnetic field. Because the 3s orbital can occupy only 2 electrons, but there is one electron, and this single electron moves with the spin either clockwise or either anti-clockwise. So when this electron moves, it creates electric and magnetic field. Due to this field, it creates like a magnet. So it is paramagnetic in nature, that is weakly attracted by a magnetic field. Example number 3. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Identify the element and its magnetic nature. Solution. We will write orbitals according to Aufbau principle: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. S orbital can occupy maximum of 2 electrons, p orbital can occupy 6 electrons, and d orbital can occupy 10 electrons. But here is 8 electrons. We will calculate total number of electrons: 2, 2, 6, 2, 6, 2, 8. It becomes 28. So 28 is the number of electrons, and neutral atom proton is also 28. So the element is nickel, a transition metal. Because the d orbital consists of 5 subshells, each containing maximum of 2 electrons. A total of 10 electrons in d orbital. But here 8 electrons are present in d orbital. That means 5 electrons singly will be present in an orbital singly first, and then 3 electron starts pairing. So 2 electrons are left. So it has 2 unpaired electrons. So it is paramagnetic in nature. That means weakly attracted by a magnetic field. Because these 2 unpaired electrons create electric and magnetic field and act as a tiny magnet. So it is paramagnetic in nature. So element is nickel. Example number 4. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Identify the element and its magnetic nature. So 1s has lower energy, 2s has higher energy, 2p, 3s and 3p is much higher energy. S orbital can occupy 2 electrons, p orbital can occupy 6 electrons. So in this electronic configuration, first we will calculate total number of electrons: 2, 2, 6 to 4. It becomes 16. In a neutral atom, number of proton is equal to number of electrons. So number of protons, 16 atomic number is of sulfur. So element is sulfur, belongs to oxygen family. Now s orbital consists of single orbital, while p orbital consists of 3 subshells. Each subshell can hold 2 electrons. So 3 subshell occupy 3 electrons singly, and then pairing starts. So 1 electron is paired. So there are remaining 2 electrons that are unpaired. So it has 2 unpaired electrons. So it is paramagnetic in nature, that is weakly attracted by a magnetic field. This unpaired electron, because it is negatively charged, these two electrons creates electric and magnetic field and act as a tiny magnet. So it is paramagnetic in nature. Example number 5. Electronic configuration is 1s2. Identify the element and its magnetic nature. So this is very simple question. S orbital has spherical in shape. One electron is clockwise, other electron is anti-clockwise. So it cancels the effect and it is diamagnetic in nature. Total number of electrons are 2. So it is helium, belongs to noble family. It has all electrons paired, so it is diamagnetic in nature, means weakly repelled by magnetic field. Example number 6. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Identify the element and its magnetic nature. So according to Aufbau principle, 1s has low energy, 2s, 2p, 3s, 3p has much higher energy. S orbital can occupy maximum of 2 electrons, p orbital can occupy maximum of 6 electrons. Here total number of electrons are 15. We will calculate 2 to 4, 4, 6, 10, 10 to 12, 13, 14, 15. 15 electrons, that means atomic number is also 15 in a neutral atom, that is number of proton. So element is phosphorus. Phosphorus is a non-metal. Now, in its electronic configuration, p orbital has 3 electrons because p orbital consists of 3 subshells, each containing 1 electron. So there are 3 unpaired electrons. So it is paramagnetic in nature, means weakly attracted by a magnetic field. So in an atom, electrons are revolving around nucleus and their spin determine whether either it is paramagnetic or diamagnetic. One electron in an orbital moves clockwise, other anti-clockwise, cancelling their effect. The shape of orbitals may be spherical for s orbital, dumbbell for d orbital, clover leaf shape in d orbital, and complex for f orbital. So in this we can identify the elements by their electronic configuration. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.